Yes, in this lecture video, let us discuss about the problem 2C. Okay, so look at the question. Give first one direct proof, second one indirect proof, third one proof by contradiction for the following statement. And the statement he has given is if n is odd integer, then n plus 9 is an even integer. I'll read out the statement once again. If n is an odd integer, then n plus 9 is an even integer. Okay. So for that, let us see how to take the uh, this one propositions. See, the first proposition we'll take it as P because this is if and then statement. So n is an odd number will comes to first proposition, that is P we have taken. After then, n plus 9 is an even integer, that comes to the second proposition. Now let us give the first direct proof for that. See, for direct proof, we need to show that P conditional to Q is true. So for that, we'll follow the steps of the direct proof. So direct proof, first step, hypothesis. Let us assume that P is true. So P is true means n is odd number, we are accepting that. So if n is odd number, that will be in the form 2k plus 1. N value will be in the form of 2k plus 1. Next step is analysis. Analysis, we have to consider n plus 9. So n we have already taken as 2k plus 1. So let us substitute in this case. So in the place of n, I have substituted 2k plus 1. Plus 9 will be as it is. That this simplifies to the form 2k plus 10. And this number, if you look at this number, this is divisible by 2. So if it is divisible by 2, we are accepting that it is even integer. Okay. So if this is divisible by 2, so indirectly n plus 9 is an even integer. So n plus 9 is an even integer means we are taking that Q is true value. Okay. So thus the conclusion will be P conditional to Q is true. Okay, because true conditional to true will always be true. So hence the proof by direct method. Similarly, next the same statement we are supposed to give a proof by indirect proof. So indirect proof, we need to show that negation Q conditional to negation P is true. Here negation we are taking opposite to the proposition what we have considered. Okay. So let us take the first step, hypothesis. Assume that negation Q is true. So negation Q means we are taking n plus 9 is an odd integer. Actually the proposition it is even. But since negation we have taken, we are taking that n plus 9 is an odd integer. So n plus 9 is an odd integer. Okay, so n plus 9 is odd integer means odd integer will be in the form of 2k plus 1. That is what we have taken in the analysis. So n plus 9 will be in the form of 2k plus 1. So this implies n value will be 2k minus 8. So if it is 2k minus 8, this is divisible by 2. So thus this is an even number. So if this is even number, indirectly it is telling that n is an even integer. So if n is an even integer, it comes opposite to the first proposition. That is n is odd integer. So we take that as negation P is true. So thus the conclusion comes as negation Q conditional to negation P is true. Hence the proof by indirect way. Then finally the proof is by contradiction. So proof by contradiction, we are assuming P conditional to Q is false. We have to go oppositely now. We should assume P conditional to Q is false. See, P conditional to Q is false means when this will be false? When P is 1 and Q is false. When P is true and Q is false. So that is what we have taken here. Assume P conditional to Q is false means because this value is 0, false. So this implies when P is true. Sorry, this is true it is. This is true. P is true and Q is false. So analysis, take Q as false. Okay, so Q as false means actually it was the proposition was n plus 9 is even, but since it is a false statement, we have to take it as odd. So if it is odd, n plus 9 is represented as 2k plus 1. So 2k plus 1, n value will be 2k minus 8. So 2k minus 8 means it is divisible by 2. So that implies n is even integer. So P is also false we are getting. P is also false we are getting. Hence the assumption what we made is wrong. Because we made our assumption P is true. Look at here. We made the assumption P is true here. But here we are getting that as, here we are getting P is false. So this contradiction leads the proof of our statement. So this contradiction leads the proof of our statement. Thus P conditional to Q is true. Hence the proof of the problem.